Simple stuff seems stupid, but it's not. And what I learned is that start from the things that I know and go step by step, not just, okay, I want to do every platform today because I want. Things won't work like that because there's little stuff that you need to figure it out. So just start with the things that you already know, put it out there, and then go step by step with the other as well. And yeah, go incrementally because you didn't want to just go with a big bang with everything, but go step by step. And of course, if you have the possibility to just go exploring other stuff to see how it works, to make it work, it's always beneficial and it's always fun. Ready to start then. Thank you very much for being here. I'm Marco. And today I want to tell you the story about releasing an app on Android, iOS, and macOS. And basically I will go through all the issues, all the quirks, all the stuff that I had to face in order to actually release it. So in this way you're gonna maybe be prepared if you're gonna go on in the same situation, or maybe I will just inspire you to bring that unreleased pet project that maybe we all have in that unreleased drawer and maybe release it, because why not? So the app that I'm gonna talk about is FeedFlow. That is an RSS reader app that I'm working on for the past 2 years in my free time, which was a fun ride. And that is built with Kotlin Multiplatform for the logic and the business logic. And on the UI side is Compose Multiplatform on Android and macOS. And for iOS, instead, I went the native way with SwiftUI because I wanted to keep myself sharp with SwiftUI. So that's the thing. And after building it, I decided to release it on their respective store. So on the Play Store, on the Apple Store for iOS, and on the again, Apple Store for macOS. And yeah, let's start with the journey, talking about the actual distribution. So the first place where I started with was Android, because of course I'm an Android developer, so I'm supposed to know that thing. Should be my job, should be my day-to-day job, so it's the easy part. So let's start from that. And I guess the majority of you are Android developers, so I'm gonna go quick in that part. But just to be just to make a comparison between all the different platforms, I'm gonna quickly share the stuff that we have to do. So in general, the first thing, we have to sign the app because we don't want to release stuff on the internet without a signature. And then we have to upload the thing on the Play Store. And then, of course, do a bunch of paperwork and review process and all that kind of stuff that is fun. But I'm gonna ignore that for today because we're just understanding the difference and the process and not the paperwork. So that was the thing for Android, pretty simple if you're doing that every day. And now let's go on the more spicy stuff, which is iOS. And it was less spicy, I would say, for me, because I already had experience in the past, so, but still a little bit different. It's not so much different for Android, because again, you have to sign the app, because for the same reason, you don't want to release unsigned stuff over the internet. And then there's an additional step required that is called provisioning, and you have to provide provisioning profiles, which is a step that is required for iOS in order to verify that the signature is actually correct, and and the app is signed with the signature that is supposed to be the one. Which is basically checking if the signature is coming from a trusted Apple developer thing. So basically, it's a step checking if you paid the $99 for being able to do the thing. And after that, you have to upload the thing on TestFlight, which is the internal thing to test app on iOS, which is basically a way to test internally your stuff and also test externally if you want. And after that, you can go through the L of the review process, the paperwork, and all the stuff to release the thing. And all of those steps are handled by Xcode. So if you want, you can just click next, 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 and Xcode will handle the thing for you. but of course I don't like Xcode, so I rather do the thing manually on CI. So if you have to do it on CI, you have to do it manually, but it's a bunch of things that are better than dealing with Xcode, in my opinion. But that's another topic. All right, so for iOS, similar things. Pretty much, except with the difference of the provisioning profile. But again, still a connection between the two things, so nothing completely crazy different. And now let's go to the even more spicier stuff, which is macOS. And before moving on, a little thing. So the macOS app that I built was a Compose Multiplatform app, so a JVM app built with a JVM tooling and system. So there's no Xcode involved here, so could be a good or a bad news depending on your taste. For me, it was a good one. And so in this case, you cannot go next in the Xcode UI, but you have to kind of do things a little bit more manual. So for the distribution, there are different possibilities in this case because we are on the JVM. So you could, for example, distribute a jar, but yeah, it's not the most user-friendly thing to just ask for user to start your jar or assume that they know what a jar is and what a JVM is. So yeah, that's a possibility, but it's a possibility, but not a possibility, I would say. So the other way is manual distributing your app. So you're gonna have to handle the distribution yourself. So you have to put your app somewhere in a website, in a storage, in whatsoever. And finally, another alternative is to upload to the App Store. But of course, it's a bit different of the manual approach. But in this way, you can use the distribution of the App Store that might be more enhanced than the SEO of your website, for example, or your social. Depends on the thing. Okay, so. Surprise, the manual distribution is easier. So at the beginning, I went with manual distribution. So what you have to do on manual distribution? Well, you can imagine that the first step is signing the app, because again, same reason as before, sign the thing before publishing it. Then there's another step, which is called notarization, which is an interesting thing that I didn't know about it. So basically, all the apps that are distributed outside the App Store need to be notarized, which is a process where you send the binary to Apple, Apple scans it to find if you're submitting malware, for example, is checking for malware, is checking if you signed correctly, and if they are happy with that, they're gonna stamp it. That's the actual name of approving. So like in a notary, you get a stamp on it. And after doing this process, Apple will know that you will know about your app. So all the gatekeeper and security stuff that there is in the macOS system knows that this is not malware, this is a real app, and you can install it. If you don't do that, you're gonna see this. So basically, Apple thinks it's a malware, so sorry, nope, you can install this thing on the machine. You might have seen it if you just downloaded a random 5 years ago tool on GitHub with the last commit 5 years ago that is not notarized because, of course, for doing this step, you need to pay the $99 to Apple. So, yeah, that was a nice surprise. Okay, so what this notarization step is. So, in order to do that, you have to call Apple with a CLI, that is the notary tool, and submit your binary and pass to Apple some, of course, your data. And then this thing is going to take some time. So Apple says in the documentation, of course, in the fancy mode, this thing can take up to an hour. In reality, it takes a couple of minutes usually. So you can pass to the command a -- wait arguments, and this will be a blocking call that blocks the CLI and waits until it's done. And after it's done, you can just staple the thing on your binary, and you're good to go. After doing this, you can install the app on your macOS machine. Of course, that was a bunch of CLI that you don't need to know. And of course, luckily, the Compose team put together a Gradle task that you can just call and forget about all the Apple CLI thingy that is underneath. Of course, it's nice to know what the thing is doing, but after knowing it, I just forgot about it and then just call Gradle and forget about it. Okay. After doing the notarization process, you're ready to distribute your app, and you have to decide a way of distributing, which could be very different. You could upload it, I don't know, to your website, to an S3 bucket, to whatever there's a storage for that, or you can just go to your friend with a USB stick to distributing it. Maybe it's not growing strategy, but you can do that. What I did, because I'm lazy, I just use GitHub releases as a hosting thing, because you can just put in the release, you can just put the notarized and prepared binary, and then user can download it for it. Of course, you have to put the URL to a more friendly website if you're not targeting tech-savvy people, but that's a way of going. Okay, now the even more spicier stuff, which is publishing on the App Store. So. Again, same thing, signing the app, because again, we need to sign the thing. We need the same thing on, like on iOS. We need to provide provisioning profile for the same exact reason. And then at this point, we can upload it to TestFlight like we do for iOS app. Same exact process, with the difference that you can install TestFlight on your Mac instead of on your phone. And to upload it, since there's no Xcode involved, I discovered that there's an app from Apple on the App Store that is called Transporter, which is basically an app that you can install from the store and then connect with your account and just start uploading stuff in that. And it will tell if there's an error or if everything is correct. And of course, first upload, I got an error because I wasn't expecting that it was working on the first trial, so nothing weird. But what the error was saying was that that my build has to include also an Intel version of it, and I was just targeting Apple Silicon because YOLO, I guess. I mean, I was doing in my free time. Apple Silicon is enough. But basically. Apparently, you need to target at least macOS 12 in order to just submit only Apple Silicon stuff, which I didn't know about it. I didn't set any minimum targeting version, so what the hell is going on? Well, apparently, in the Compose Multiplatform Gradle plugin, there's a nice hard-coded minimum version of macOS. Okay, so another weekend passed, and let's fork Compose Multiplatform. So I forked it, I found all the hard-coded stuff, and I replaced it. So with Compose 1.6.10, you can just customize the thing and then say a minimum version, which is what I did, and then no inter-machine targeted, sorry, not sorry, but yeah, that's the thing. Okay. At this point, I was, okay, we have everything ready, let's launch it. I got my build on TestFlight, I'm ready to start my first launch of the app. Which, of course, an error, because again, first run, things never works. And at this point, the error was a weird thingy, so basically Apple is thinking that SQLite is a malware, so what the heck is going on here? Another deep dive into things. I discovered that basically apps that are macOS app on the App Store are running in a sandbox, which is basically a thing from Apple that, in order to protect the privacy of the user, so random macOS app in the store cannot access your file system, for example. You cannot get all the stuff in your file system, and also you cannot run random code from the from your file system, which is something that usual malwares does. For example, you just load code dynamically and do weird stuff. Okay, so in order to understand how to solve the issue, I had to understand how native libraries works on the JVM on desktop. So basically, if you have libraries that use native libraries like SQL, for example, these native libraries are embedded in the jar of the dependency. So how the JVM works is that it just, when you need that thing, the JVM unpack it, extract the library, and then it's loaded on your system. And basically, if there's no sandbox, it just unloaded the thing in a temporary directory, a random directory in the private var folder. So you can do whatever you want. So you just unpack the thing there, and then it loads. If you're running with a sandbox, it's doing the same thing, with the exception that is placing the thing in a temporary folder inside the sandbox. But you cannot do that because because Apple thinks it's a malware, because that's the exact thing why there's a sandbox to not dynamically load code randomly. So how to do that? Well, if you just sign it and you put it inside the binary, then it's not malware. You're good to go. And basically, that's the way. But in order to do that, you have to actually find the library that you're using in order to embedding it. So another deep dive to just find the transitive dependency on SQLite, which I found out that is SQLite JDBC, the classic thing. And by looking in the repo, you can find the resources with the native libraries. So I found it for my architecture, which is, again, only Apple Silicon. And after I found it, okay, I can just put it inside the binary. So to put it inside the binary, you can put it in a random folder on your machine. And then if you use a specific format, then the Compose Gradle plugin will pick it up. So you can put for architecture-specific libraries like this. You can put OS-specific libraries, or you can put common-specific libraries. And not only libraries, but resources that you need in your binary. So maybe, I don't know, sound, images, or whatsoever. And then, of course, you have to tell to the Compose Gradle plugin that actually is a folder where to get stuff and put it into the binary and sign it. So you need to just set the app resource root directory. And after that, you have to manually load the libraries for yourself, because you need to override the thing that JVM does. So if the app is running in a sandbox, which you can get by checking environmental variables, then you can get the path from where that binaries, where the signed native libraries are put, which is in this case compose.application.resources.dir. And then at this point, you can tell to the JVM where to get those native library, which in this case is specifically for SQLite and a specific path. But apparently, you can make it general and just make it general for every library, so you don't have to do platform-specific stuff. Of course, I mark it as a future improvements. Maybe it's more like it's working. I won't do any more improvements, but let's see in the future if I gonna do that. So after all this madness, I finally had an app that was working, and I published on the App Store, and Apple was happy, and I could just use it. So nice. Okay. But of course, after releasing the thing, you have to check if things are going good or going bad. So you need to check for crash and maybe logging and stuff like that. So for the mobile side, it was pretty straightforward, because I just go with the standard things that I always use. So Firebase Crashalytics in this case. But for desktop, I never done a desktop app, so I have no idea what to use. And that was the things that come in a bit. But first another thing. So at the same time of Firebase Crashalytics, there's another library that I suggest you to use, and that I used, which is CrashK iOS, which is basically a way to get proper crash report for Kotlin code that is running on iOS. So you can just get the line that failed instead of just a random memory address that you can have no idea what's going on and where to find the thing. But with CrashK iOS, you get the actual line where things went south. So pretty a must-have library. Okay, so the topic that I was telling you before, I had no idea what to use on desktop. So I found out that there's a Sentry Java SDK, which of course works on Kotlin, and it's also sell it as a Kotlin thing, but it's called Java, but that's another, not a marketing guy. So I just use that, set it up, and it's working so far, so good. Okay. So also I wanted to log some stuff because people that build RSS feeds are pretty much creative, especially with date formats and stuff. So sometimes the parsing of the dates are failing, and I want to check that if things are. Of course, I'm not crashing the app because that date doesn't format correctly, but I want to check that. So for logging, I'm using another library from TouchLab that is Kermit, which is basically abstract the classic logging stuff, so the usual level of logins that we are all using. And yeah, basically you can define your logger. You can say use the platform log writer, which on Android will be logcat, on desktop will be the standard output, on iOS will be the whatever iOS is using for logging. And you can also add more writer, like for example, if you're using Timber, you can plant more tree. And in this case, I'm just having a log writer for crash reporting, which will save the logs on the crash reporting tool that I'm using. So for example, for mobile, it's using Crashlytics log writer, which is coming by default with the library and the integration with CrashK iOS. Instead, we for Sentry, of course, it's a customized thing. There's no Sentry thingy that's coming from the library, and so I had to write it by myself. But it's pretty straightforward because the library exposes a log writer thing that you can implement with a simple isLoggable method and a log method that calls whatever tooling you're using. Maybe you're printing the logs in a file or whatever. In here, you call whatever wherever you want to send your logs. Okay, and that was it for observability. Then another thing is internationalization. So I wanted to translate the app in multiple languages because why not? But of course, I'm lazy, so I didn't want to translate it to have copy-pasted into 3 different platforms because nope. So I looked to a thing where I could just have a single file with the translation and then use it in different platforms. So for that, I did a bit of try a little bit of different things, and I end up using Lyricist, which is a nice library. Of course, I had to fork it and change some stuff for my use case, but that was not a specific use case, but it was actually useful. So they accepted it. But basically, with Lyricist, you can define, for example, your translation directly on Kotlin code, or you can have it on XML and then KSP generates Kotlin for you, which is interesting. So in this way, I can have the XML, which is the standard for Android, have it on crowdsource tooling for translation, so people in the world, if they want to translate the thing, can do it on a known format, and then I'm happy with all the things on my side. So with Lyricist, you can define, you're going to have a map with the language code and your translation, which is automatically generated, in this case, from KSP, I guess, but you can also customize it if you have different stuff. And then on Compose, it works with composition locals. So at the entry point of your app, you can have composition local that provides the translation. So all you need to do is just accessing the local composition for the strings and get the correct translation for your things. So pretty easy and nice to use. And of course, I wanted to use on iOS as well because why not? And of course, it's not working out of the box for SwiftUI, but I wanted to use it, so I made it work with a bit of a hack. So in this case, we are starting again from the same map with the same things. And then what I'm doing on the iOS side is getting the language code and the region code from the iPhone. And then in my project, I'm using Coin as a dependency injection. So I'm passing to, initializing the thing inside the common code. So from the iOS side, I'm passing the things. I'm passing the language code and the region code to Coin, basically. And then in the common code here, I'm exposing the actual translation, which is the value of the things that was in the map. So in this case, I'm checking if things went south and there's no language code. And this is the classic command, this should never happen, but cool, who knows. But in this case, I'm just fall back into English because why not? And then if there's no region code, I'm just checking without it and defaulting to English as well. And otherwise, I'm just building the language, locale stuff, and then again getting with the different fallbacks in cascading. And then I can have this thing exposed with a super nice static thingy on iOS. And then on my SwiftUI views, I can just access the thing and it's working. I can just write this thing and have the correct translation. And it's working nice, also because when you change language on iOS, iOS will kill the app and start it again. So no need to handle restoration, stuff like that. Just kill everything, and so nice. Okay, so with this thing, everything works. I have my translation in a single place, and I'm happy with that. Okay, little bit of things, and let's try to wrap it up, the things that we've seen today. So, of course, simple stuff seems stupid, but it's not. And what I learned is that I should start from the things that I know I should and go step by step, not just, okay, I want to do every platform today because I want. Things won't work like that because there's little stuff that you need to figure it out. So just start with the things that you already know, put it out there, and then go step by step with the other as well. And yeah, go incrementally because you didn't want to just go with a big bang with everything, but go step by step. And of course, the thing that you may have wondering is why. Yeah, that could be a very good question because it's a lot of things that you have to explore. But yeah, in general, from that thing, I like to explore other things, other stuff that you're not using every day. So yeah, in general, if you have the possibility to just go exploring other stuff to see how it works, to make it work, it's always beneficial and it's always fun. Of course, things can go bad, but yeah, if you can try, it's fun. So of course, this was through a span of multiple weekends, for example. But yeah, it was fun. I enjoyed. So yeah, you can. I hope that it was that maybe it was helpful if you're gonna be in the same situation, or just inspire you to just release your stuff that you have in your unreleased drawer. All right. I went more deep into more topics that I couldn't cover here because it's not coverable in a sort of way. But I automated everything with CI because again I'm lazy. I just want to push the things and then the machine do it. So if you want to build a pipeline similar to publish all the way on how I did it, you can check the articles, or you can fork the source code because the app is open source, so you can find it on my GitHub. And with that, it was it. Thank you very much. If you have any kind of question, if you have time, I'm here. Otherwise, you can catch me around. And yeah, thank you.